Good day everyone, isang mapagpalang araw sa ating lahat at welcome to my math class. Muli, ako ang inyong likod, Sir Jolan M. Sereno. And for today's tutorial, ang ating lesson is about the graph of polynomial functions. So for this lesson, you're expected to describe and interpret the graph of polynomial functions. For our math concept for today, polynomials may also be written in factored form and as a product of irreducible factors. That is, a factor that can no longer be factored using coefficients that are real numbers. So, here, sa part na to, pinapakita na natin na ang polynomial functions ay hindi kailangan naka-standard form, no, bago siya may graph or ma-solve. No, there are times na makikita natin yung functions natin naka-factored form. So, para lang may idea kayo na pwede pala yun. So, example, dito, sa ating picture na to, in this part, our polynomial function here is equal to x squared plus 4x plus 4. So, kapag pinactored form natin to, so, ibig sabihin, kukunin natin muna yung factors niya. So, what are the factors of x squared plus 4x plus 4? Ang factors niyan is x plus 2 times x plus 2. Or simply, you can write x plus 2 quantity squared. So, yun yung factor niya. So, pwede mo siya isulat ng ganito. So, parehas na yung magiging behavior niyan, yung output niyan, once na-graph mo siya or kinumpit mo yung mga roots niyan or zeros niyan. So, yun sinasabi natin na pwedeng naka-factored form din ng ating polynomial function. Okay? Next, concept. No? For our understanding the math concept, first, in this lesson, we need to take note that the graph of any type of functions must pass the vertical line test. So, medyo familiar na kayo dito sa vertical line test kasi nababanggit na to sa mga previous years ninyo sa pag-aaral sa math. But, balikan lang natin. Again, what is a vertical line test? Is a visual way to determine if a curve is a graph of a function or not. So, para malaman lang natin kung ating graph ba ay function or not. So, paano ba natin gagawin yun? Just simply use a ruler or straight edge and draw a line parallel to the x-axis. So, ito yung x-axis natin. So, parallel dapat yung ating vertical line sa x-axis. Ayan. So, ito sa drawing natin, ayan. Meron tayong dalawang parallel lines dito, a vertical line that is parallel to the x-axis. Okay? Now, so, pag na-drawing niya namin yan, sir, so, paano yung malalaman kung alin dyan yung function at alin dyan yung hindi? So, kapag may vertical line ka na na-draw, so, ang gagawin mo lang dyan is to check, no? If the graph intersects more than once for any value of x, then the graph is not a graph of a function. If alternatively, a vertical line intersects the graph no more than once, no matter where the vertical line is placed, then the graph is a graph of a function. So, simply kapag tumama yung ating vertical line sa graph more than once, so pwedeng twice, 3 times, 4 times, no? Basta more than once tumama yung ating vertical line sa graph, hindi na siya function. So, yan yung nangyari dito sa ating second illustration dito. At dahil yung graph natin ay pa letter C, ayan, and then nagdraw tayo ng vertical line, so tumama siya sa dalawang points doon sa given graph. Kaya siya hindi function. Compared mo dito na once lang tumama yung ating vertical line. Ayan. Sa point lang na to siya tumama sa ating graph. Therefore, function to. Ayan, ganun lang. Ganun lang siya ginagawa. Okay, visually. Okay. Next, second concept natin. Every polynomial function with real coefficients has the set of real numbers as its domain. Hence, it is continuous function. This means that the graph of a polynomial function has no breaks, holes, or gaps. So, ibig sabihin, ang graph natin continuous, no? Dire-diretso. Once na nag-drawing tayo, dire-diretso siya. No? Wala tayong putol sa graph, no? Wala tayong pag-skip or wala tayong gap. Continuous yung ating graph. Like ito, sa ating illustration. Okay? Yan. So, in that case, nasabi natin na dapat yung graph natin, once na nag-start tayong mag-draw, ay dire-diretso. Hindi natin kailangan iangat yung ating marker dyan. Ayan. So, like ito. Okay, next, number 3. A polynomial equation of the nth degree cannot have more than n roots. This only means that the graph cannot intersect the x-axis more than n times. So, sinasabi lang dito that yung number of roots natin ay nakadepende sa ating nth degree or yung degree ng ating function. At hindi pwedeng lumagpas yung roots natin, yung dami ng roots natin sa degree ng ating polynomial equation. For example, naka third degree polynomial ka. Therefore, expected to have at most 3 roots, number of roots. So, hindi naman pwede mangyari na naka third degree ka bago nakakuha ka ng 4 na roots niya. So, hindi pwede mangyari yan kasi nga dapat hindi mag-exceed dun sa dami or sa bilang ng ating degree or sa highest exponent ng ating polynomial. So, yun siya sabi sa ating third concept. Okay, and then our last concept dito, a graph of a polynomial function has only smooth, rounded turns. A polynomial function cannot have a sharp turn. So, ibig sabihin, pag nagdo-drawing tayo, kailangan pag nagkakaroon tayo ng mga turns, like itong graph na to, nagkaroon siya dito, ito yung kanyang first turn. So, umikot na siya, nag-turn siya dito. So, as you can see, smooth yung ating turn dito, yung kanyang turning points dito. And then, nag-turn siya ulit dito, smooth ulit yan, pataas. So, ganun dapat yung magiging itsura ng ating graph. Compared mo dito sa second illustration, mula dito sa left side, pababa, as you can see, ayan, no? So, sharp yung kanyang turn. So, halos hindi siya, parang walang nangyaring likod. Diretso angat agad, no? After this point, umangat agad yung graph. So, this is not an example of a graph of a polynomial function. Okay? Ayan. So, those are the concepts natin. Okay, so simulan natin ngayon sa zeros of polynomial function. So, these are the parts na kailangan natin, mga concept na kailangan natin tandaan every time na nag-aaral tayo about the graph of a polynomial function, yung zeros niya. So, ano ba yun? No? It can be shown that a polynomial function of degree n, the following statements are true. First, the function has at most n real zeros. Okay? So, ibig sabihin, yung zeros natin is also like the roots. So, nakadepende siya sa nth degree. Sa degree ng ating polynomial function. So, like what I said kanina, kung naka third degree polynomial ka, therefore, expected to have 3 roots. So, ganun din yung number of zeros mo. 3 din. No? Kasi halos nag-interchange lang naman, no? Yung paggamit natin ng term na zeros and roots kasi halos same lang din sila ng concept. And then, the graph has at most n minus 1 turning points. So, we're going to use this formula n minus 1 to get the number of turning points. So, yung n is the degree of the polynomial and then minus 1. So, ito yung gagamitin natin to identify the number of turning points. Okay, now, sir, ano nga ba ulit yung turning points? So, turning points, relative maximum or relative minimum, are points at which the graph changes from increasing to decreasing or vice versa. So, ito yung time na nag-shift na, no? Kasi dahil nagte-turn siya, so it's either pag lumiko yung ating graph, pwedeng pababa siya, or pwedeng pataas na yung graph natin. So, depende yun, no? Pwede namang pataas, and then pag nag-turn siya, bababa naman na siya. So, depende sa magiging end behavior niya, ng nature ng ating graph. Okay, but just for the identification and solving for the number of turning points, ang gagamitin na nating formula dito is n minus 1. Okay? Ayan. So, let's solve together. So, tingnan natin kung ma-apply natin yung mga natutunan natin kanina. Let's have our first example. Example number 1. How many turning points does f of x is equal to x cubed plus 3x squared minus x minus 3 have? And find all the zeros of the function f of x is equal to x cubed plus 3x squared minus x minus 3. So, ito yung ating problem sa example na to. Okay, so first, let's answer the question, how many turning points does the function have? So, ang sagot natin dyan, the graph has at most, so gagamitin natin yung formula, n minus 1 turning points. And the degree of the function is 3. So, sir, bakit naging 3? Ito, titingnan lang natin ulit. Nasa leading term siya, or simply siya yung highest exponent, yun na yung ating degree. So, the degree now is 3. Therefore, 3 minus 1, we can now say that the graph has 2 turning points. Ganun lang, mentally, kaya natin siyang masagutan agad. No? Makita lang natin yung function, para masasabi natin agad kung ilan yung turning points niya. So, in this case, ang turning points niya ay 2. Okay? Next, let's find all the zeros naman of the function. So, first step natin dito is to set the equation. So, gagawin mo natin equation yan. So, what will happen is i-equate natin to sa 0. So, we have now x cubed plus x squared minus x minus 3 is equal to 0. And then, solve. So, ano ba yung solve na sinasabi? Ang solving natin dito is yung roots niya. No? Kasi doon kayo unang natutunan sa roots. No? But in this quarter, ano na siya? Magiging zeros na siya. Na yung term na gagamitin natin. So, by synthetic division, familiar na kayo dito, nagamit na natin to nung first quarter in synthetic division sa pagkuha ng factors at syempre ng roots. Okay? So, here, so ganoon lang din ulit yung process niyan at gagana ito. So, again, kapag naging remainder natin ay 0. So, doon natin masasabi na yung number or integer nilagay natin dito sa box ay one of the roots or zeros of the given function. So, saan nga ba nanggagaling yung mga numbers na nilalagay natin dito? Yan ay manggagaling sa ating constant. Siya yung mga factors ng ating constant. So, in this function, we have negative 3 as our constant. So, what are the factors of negative 3? So, you have negative 1, and then you have 3. Then you have negative 3, and then you have positive 1. So, yun yung mga possible na pwede natin gamitin. So, in this, gamitin muna natin si negative 1. And then, same procedure na ginagawa natin sa synthetic division. First is we write the numerical coefficients of x dito sa first row. And then, we bring down the first number. So, you have here 1. And then, you multiply it here. So, negative 1. So, you have negative 1. And then, we add. So, you have 2. And then, repeat the process. As you can see, ang last number natin dito ay 0. Therefore, the remainder is 0. At tama na ang negative 1 is one of the zeros of this function, polynomial function. Okay? And then, so isa na yan. So, kailangan natin ay 3. So, to get the other 2, so, magpuproduce tayo ulit dito ng panibagong polynomial mula dito sa ating synthetic division. Gagawin nating polynomial itong 1, 2 at saka negative 3. So, magiging x squared siya. So, alam niyo naman yung process niyan. Yung magiging literal coefficients niya ay minus 1 lang yung degree. So, magkisimula tayo sa x squared plus itong 2 ay may 2x and then the constant negative 3. So, ito naman yung gagamitin natin para sa ating next synthetic division. And then, dito, ang ginamit natin ay positive naman, positive 1. So, same procedure, bring down the first number, multiply mo dito sa ating possible na 0. So, 1, that is 1, 2 plus 1 is 3, 3 times 1 is 3, and then 0. So, nag-0 ulit, remainder is 0, therefore, 1 is one of the zeros. No? Dito ang positive 1 natin ng ating polynomial functions. And then, so magiging polynomial ulit. So, naging ano na siya, x plus 3, binomial. So, dito, nagating sa binomial, hindi na natin kailangan mag-synthetic dyan. So, pwede natin directly makuha siya by equating this binomial to 0. So, you just equate this, x plus 3 is equal to 0, and then you solve for x. Therefore, the value of x here is negative 3. So, yun ay pangatlo. So, we can now say that the zeros are negative 3, negative 1, and 1. And these are also the x-intercepts. No? So, yun din kasi yung concept ng x-intercepts natin. No? Ito yung mga points na tatamaan ng ating graph sa x-axis. And also, sama na rin natin dito yung y-intercept. Yung ating first lesson is about getting the intercept. So again, to get the y-intercept, we just let x equal to 0. So kung gagawin nating 0 ang lahat ng ating variable x dito sa ating function, lalabas na ang matitira dyan ay yung ating constant, which is negative 3. Kaya madali natin nasasabi at nakocompute yung y-intercept. Okay? So that's it. That's how we solve for the zeros of the polynomial function. Okay. Next thing to consider naman is yung multiplicities of zeros. So, kailangan din natin ito para may graph natin ng maayos ang ating polynomial function. So, ano ba yung multiplicity of zeros? The multiplicity of a zero is the number of times the real root of a polynomial function results in f of x is equal to 0. So, ito naman yung bilang ng appearance, no? How many times lalabas ang isang root sa isang function, no? Pwede kasing nadodoble yung roots natin, minsan natin triple. So, depende yan, no? Kaya meron tayong tinatawag na multiplicity of zeros. Okay, so first, here, suppose R is a zero of even multiplicity. Then, the graph touches the x-axis at R and bounces at R or is tangent to point R0. So, here, yung R natin is the root, no? If this is a 0, so even multiplicity, ibig sabihin, pag even, so 2, 4, 6, 8, 10. So, yun yung beses na naulit yung root or yung 0. So, ano mangyari? The graph touches the x-axis at R, dun sa root niya, sa 0 niya, sa intercept niya, and then bounces at R, bounces back, or it's tangent. So, mamaya malalaman nyo paano ba yung pag-tangent or pag-bounce niyan. Okay? And then, kapag naman ang zeros natin ay add multiplicity, ibig sabihin, 3 times na ulit yung ating zeros, or pwedeng 5 times na ulit, or 7 times. Ang mangyayari naman, then the graph crosses the x-axis at R, or doon sa intercept niya, or doon sa root niya. Doon siya dadaan. Okay? Or doon sa x-intercept. And then, last is, regardless of whether a multiplicity is even or odd, the graph tends to flatten out near zeros with a multiplicity greater than 1. So, yun yung magiging concept natin or magiging scenario natin sa pagka-graph, no? So, it's either it's even multiplicity or odd multiplicity. Okay, so, by illustration, ganito siya para mas maintindihan niyo. Ayan. Pag sinabing even yung multiplicity, ang mangyayari is, di ba, ay tatouch siya doon sa ating point, sa ating 0, or doon sa ating y-intercept, doon sa R, and then bounces back. Ayan. So, if this is the graph, so ito yung kanyang one of the x-intercepts or the zeros. So, pag nag-touch siya dyan, hindi siya didiretso pa ba, kundi pagka-touch na doon, babalik siya, babounce siya, pataas. Okay? And then, ayan, may turning points doon. And then, dito ulit, meron ulit siya ditong multiplicity na even, kaya ulit siya nag-bounce, pataas. So, ganun yung magiging behavior ng ating graph. So, hindi siya tumutuloy papunta sa quadrant 3 at saka 4. Nandun lang siya sa quadrant 1 and 2 ng ating Cartesian plane. Kasi nga, yung multiplicity niya dito, even. Okay? Now, dito naman, kapag add naman yung multiplicity, ibig sabihin, crosses the x-axis. So, as you can see here, itong graph na to. Ayan, no? So, dito, so, turning point niya to, pero ito, hindi siya nag-bounce back, no? Dumiretso lang siya pababa. Ito yung kanyang, 0 eh. Intercept niya to, pero dumiretso lang siya pababa. So, ganoon din dito, hindi din siya nag-bounce back. Dumiretso siya pababa, papunta dito sa quadrant 3 and 4. Ayan, papunta dito sa y-axis. Oh. And then, may turning point siya dyan. Tapos dito, hindi siya nag-bounce back. No? Hindi siya nag-bounce, nag-turn pababa. Dumire-diretso lang yung ating graph. Kasi nga, yung multiplicity niya dito ay odd. So, ganun yung magiging itsura niya. So, sir, pwede bang magsamahan yung dalawa? Yes, no? There are some cases na dito, nagko-cross siya, tapos darating sa point na dito, magbabounce back naman siya pataas, no? Pwedeng ganun, no? Pwedeng wala dito, yan, nag-cross siya dyan. Pero pagdating dito, pwede siyang mag-bounce pataas. Depende kapag yung second zeros niya ay 3 times na naulit, 5 times na naulit. So, pwedeng magsama yung dalawang yan. So, but dito, pinaghiwalay muna natin yung may even na multiplicity at saka yung may add multiplicity in terms of the zeros of the functions. Okay? Ayan. So, yan yung mga sample na mag-iitsura ng ating graph. Okay, next example tayo. No? Let's solve for the zeros of this function. So, papansin niyo itong function na to ay hindi naka-standard. Ito ay naka-factored form. Ayan. So, you can see, naka-factors yung mga given niya. X squared times the quantity x minus 2 squared. So, factored form ito. Ito yung sinasabi ko kanina na pwedeng nakaganito na agad yung ating function. Hindi siya naka-standard. In this case, pwede pa rin natin siyang isolve. Mas madali pa nga ito. So, tingnan natin. Sabi, show then also the graph. Okay, so let's start. So for our solution, so solve for the zeros of the function, then show the graph. So first step natin, set up the equation. So ganun pa rin, equate lang natin to sa 0. So you have x squared times the quantity x minus 2 squared is equal to 0. Ayan. So kagandahan dito, hindi tayo dito mag-synthetic division like what we did sa first example. Bakit sir? Kasi nga, factored form na siya. So, ibig sabihin, ang given ay factors, mga factors niya na. So, pwede na natin siya idiretso sa pagkuha na agad ng value ng x. So, by using the zero product property. So, kung familiar kayo dito, mas madali ito para sa inyo. So, ang gagawin lang natin dyan, yung mga factors natin, pag-iwalay lang natin ito, and then, equate na natin siya agad sa 0 kasi naka-factor na siya, factored form na siya. So, diretso na tayo sa values of x. So, in this case, so itong x squared is equal to 0. So, again, balikan natin. Ano ibig sabihin ng x squared? Sabihin, sinimplify niya dahil meron tayong dalawang x, no? X times x equals to x squared. So, therefore, we can now say that x equals to 0 to the multiplicity of 2. Bakit? Kasi, twice na naulit yung x. No? So, again, x is equal to 0. Yun yung value ng x mo, 0. Dahil nga naka-squared siya, so twice siyang nangyari. Kaya, ang x natin is 0, twice siyang nangyari. Hindi naman natin sulat ng 0 and then 0 sa pag-list down ng mga intercept. So, nalagay natin dyan, multiplicity of 2. Ibig sabihin, naulit ng dalawang beses yung value ng x na 0. Okay? And then the second one naman is yung x minus 2 quantity squared is equal to 0. Equate natin sa zeros yan. So again, tandaan natin na itong x minus 2 quantity squared ay yung simplest form na itong factor na to na x minus 2 times x minus 2. No? Kasi nga dahil dalawa siya, ini-squared na lang. Now, in terms of getting the value of x, so napakadali naman kunin ng values of x na ito eh. Yung value na x na ito natin, kapag naka-binomial na, you just simply transpose the constant to the right side of the equation. Therefore, your x is 2. So, therefore, we can now say that the value of x now is 2 to the multiplicity of 2. Kasi, twice itong naulit eh, no? Dalawa yung x minus 2 natin. Kaya, multiplicity of 2. So, parehas na even multiplicity yung ating mga zeros. So, ang mga zeros niya, dalawang 0, tsaka dalawang 2. Kasi nga, ang degree natin dito ay 4. Kasi naka-raise sa 2, naka-raise sa 2. So, therefore, naka-4th degree ito. Kung ito ay gagawin mo standard form, ang highest exponent mo dito ay 4. Kaya ang degree mo dyan ay 4. Okay? Ayan. So, parehas naka-even multiplicity. Okay? So, sana na-gets nyo yung paano siya kinuha. So, mas madali ito. Hindi na kailangan mag-synthetic division dito. Kasi nga, factored form na siya. Okay? Now, to show the solution, so, ano ba magiging itsura ng graph niya? Ganito. Ito magiging graph niya. So, the exponent tells us the multiplicity. So, kung mapapansin nyo kanina, parehas naka-raise sa 2 yung ating factors. So, the graph of the polynomial function as shown at the right is tangent to the x-axis at points 0, 0, and 2, 0. So, again, yung 0 natin, twice siya na ulit. Ayan. Kaya, nung yung graph natin, so, pababa. Okay. So, pagdating sa 0, nag-tangent, nag-bounce back, pataas. Okay. Nagkaroon ng turning points. Tapos, nag-bounce din siya ulit dito sa 2. Kasi nga ay twice din yung naulit. No? So, nag-bounce siya pataas. Okay, so ang magiging itsura ng graph natin ay pa W. Ayan. Kasi pareha siyang naka even multiplicity. Okay? Ayan. So, that's it. That's how we graph a polynomial function in a factored form. So, mas mabilis siya kasi nga factored form na siya. Okay? So, ito yung magiging itsura niya. Okay. That's it. Now, last is for the behavior of the polynomial function. So, the behavior of the graph of a function to far left and far right is called its end behavior. So, yung dulo-dulo. Ano ba magiging itsura or behavior ng graph natin? Yung right side at saka yung left side ng ating graph. Okay? So, although the graph of polynomial function may have intervals where it increases or decreases, the graph will eventually rise or fall without bound as it moves far to the left or far to the right. Okay? So, how can we determine the end behavior of a polynomial function? So, in this part, so, nagawa lang tayo dito ng table para mas madali yung makita, no? Yung ating end behavior ng graph, no? Paano ba siya nagpapalit-palit in relation to the leading coefficient and degree of the polynomial function. So, ito yung dalawang mahalagang factors o bagay na nakakaapekto sa end behavior ng isang graph. Yung leading coefficient, nanggagaling yan, makikita yan sa leading term, at yung degree of the polynomial function, sinabi ko na ito kanina, po ulit, ito yung highest degree ng given polynomial function. So, doon lang sa dalawa, ang i-consider natin, no, sila lang naman kasi makakaapekto sa end behavior ng isang polynomial function. Okay? So, ito yung table, ito yung summary para mas madali nyo siyang mapag-aralan. So, simulan natin dito. Itong first column natin, ito yung mga sample ng function. So, papansin niyo puro lang yung leading term. Kasi yun lang naman yung nakakaapekto sa end behavior ng isang graph. Yung kanyang leading term. No? So, wala nang effect yung second term, yung constant dito. Puro lang leading term. Okay? For example, ang ating function ay x squared. Nagsimula sa x squared. Or, we can now say that the a sub n o yung leading coefficient, yung numerical coefficient ng ating variable ay greater than 0. So, ibig sabihin, pag ito ay positive, for example, you have 2x squared, 4x squared, 5x squared, to positive infinity, dito siya papasok. Okay, hindi ibig sabihin ng x squared ay 1 lang, no? Sinasabi dito that yung a sub n is greater than 0. So, magsisimula sa 1, tas 2, 3, 4, to positive infinity. And then, ang ating degree ay 2. So, even yun. Ayan, no? 2. Even yan. So, what will happen, ang magiging graph mo ay ganito. Ayan. Letter U. Ayan. So, dahil even siya, diba? Like kanina yung zeros of multiplicity, magta-tangent siya or magbabounce siya pataas or pababa. So, depende na yun. No? So, dito, dahil ganito ang kanyang behavior, pareha siyang rising. Yan, rising sa left side ng ating Cartesian plane at sa right side ng ating Cartesian plane. So, pag ito yung condition niya, ito yung given niya, ito yung magiging behavior ng ating graph. Okay? Yan. Next naman, what if sir ay negative nagsimula? So, negative x squared. So, pwedeng negative 2x squared, negative 2x squared, negative 5x squared. So, ang magiging a sub n mo dyan is less than 0 kasi nga negative. Pero ang iyong degree ay even pa din, no, 2, 4, 6, 8, 10. What will happen to your graph? So, pag naka-raise sa 2, ganito siya. Siyempre, ang turning point yan, isa lang. No? Kasi nga 2. No? Minus 1, di 1 lang yung turning point niya. So, ganito magiging behavior niya. Okay, so parehas falling. Opposite siya nung una, kasi nga nag-negative eh. So, opposite siya. So, parehas falling dun sa left hand ng ating Cartesian plane. Tapos, sa right side ng Cartesian plane, falling din yung ating graph. Okay? Third, what if sir ay positive naman, pero odd. So, dito ay naka f of x equal to x cube. X cube yan. So, still, yung a sub n natin is for the greater than 0 or mga positive numbers, simula sa 1, 1, 2, 3, 4, 5 to positive infinity. Pero ang ating degree ay odd number. Ayan. So, what will happen to the graph? So, magiging ganito siya. So, mapapansin ninyo ay meron siyang, yung behavior niya, yung end behavior niya ay falling sa left side, pero rising sa right side. So, pababa siya dito sa left side ng ating left part. Itong nasa quadrant 2 and 3 ng ating Cartesian plane. Pero pagdating dito, pataas na siya. Ito. Okay, so falling and rising. And then last is, what if negative yung ating naging a sub n, less than 0, negative yung ating numerical coefficient dito, but still, the exponent is an odd. So, ito ang magiging itsura niya. So, opposite lang din ito. Ano naman siya? Mangyayari naman, kung falling dito kanina, dito naman ay rising siya to the left hand natin, and then falling siya dito sa right hand ng ating graph. Ayan. So, ayan yung summary ng magiging end behavior ng isang graph ng isang polynomial function. Okay. That's it. So, and we're done for today. Thanks for watching. Sana may natutunan kayo. Kung may natutunan kayo at sa tingin nyo makakatulong to sa mga kapwa nyo mag-aral, please click the like button and share it to your friends, and subscribe na kayo sa aking YouTube channel para mas updated kayo sa mga tutorials natin, especially sa Mathematics 10. So, thank you very much. Stay healthy and safe. God bless us all. Muli, ako ang inyong lingkod, Sir Jolen M. Sereno. Maraming salamat.